Hello students, in this video we'll be discussing about cluster analysis of module 4. What is cluster analysis? Cluster analysis is the task of grouping a set of objects that are similar to each other or near to each other in the same cluster and the data points or set of objects that are far to each other and are dissimilar from each other in a separate cluster. And it is used for automatic identification of natural grouping of things. It is also known as segmentation technique. And as I said, in this technique, data instances or objects that are similar to each other or near to each other will be placed in the same cluster, and data points that are far from each other and dissimilar to each other will be placed in the different clusters. And it is an unsupervised machine learning technique, and the quality of this clustering result depend upon three factors, that is the algorithm, the distance function and the application. And for clustering we are having different types of algorithms known as K-means algorithm, K-medoids, Clarence, right? So we are having different algorithms, and to calculate the distance between the data points and the centroids, we can either use Euclidean distance function, Manhattan distance function, Minkowski distance function, or Jaccard distance function, and the application for which I am using this clustering. So these are the three factors that affect the quality of the clustering. And here in our syllabus we'll be learning about K-means clustering. So these are the steps in K-means clustering. So first I have to decide the number of clusters. So this number of clusters is denoted by the value K. So K value I have to decide at the very beginning itself. And then I randomly choose K vectors as the initial centroids. First decide the number of K values, then for every cluster I have to randomly choose an initial centroid. So if I have decided K is equal to 2, so then I have to find two initial centroids. Then the third step is I have to compute the distance between the data points and these centroids, and create the partition of data by using minimum distance criteria. So when we discuss the example, we will understand this step better. And revise the centroids using the clusters formed in the previous step. Repeat the process of partitioning and revising the centroids until the clusters are stabilized. So these are the steps of K-means clustering. So we will discuss an example. So this is the data set given. You are given with 5 objects, and you are supposed to cluster it, right? You are supposed to cluster it. So consider the data set consisting of 5 objects and the 2 variables as given below. You have to make clusters. So first I have to decide this K value, right? So in K-means clustering, the very first step is I have to decide the K value. So here K I have decided as 2, right? So I have to choose 2 centroids. As I have decided the number of K is equal to 2, I am supposed to choose 2 centroids. So a centroid is nothing but the center of a cluster. So some value near to this value in the given data set, I have to choose it as the initial centroids. I'll repeat, some value, right? So centroid is nothing but center of your cluster. So some value near to this value in your data set you have to choose as the initial centroids. So I have chosen the first centroid as 150, 45. So you can check here 150, it's not there, right? So some random values I am choosing as my centroids, but it should be somewhat close to these values. So 150, 45 I have chosen, and the second centroid I have chosen is 160, 55. 160 comma 55. So 160, it is there already in your data set. No worries. Right, you can proceed. Now what I have to do, I have to calculate the square distance between the data points. Right, you are having 5 objects. So I have to calculate the square distance between the 5 objects and the centroids. I have 2 centroids. So first I will calculate the square distance between the 5 objects and the first centroid, that is 150 comma 45. And in the next step I will be calculating the distance between the 5 objects and the second centroid, that is 160 comma 55. So you can check your data set. It is 160 comma 56. So it is 160 minus 150, which is your initial centroid, square it, plus 56 is the first object weight in your data set. 56 minus 45, the whole square. Calculate and write it. Similarly for the next object, 156 comma 48. 156 minus 150 plus 48 minus 45, the whole square. You can calculate and write the distance. Similarly, you are supposed to write for the other data points or the other objects. Next step is I have to calculate the square distance between the 5 objects and the next centroid. What is my next centroid? 160 comma 55. Right. So 160 comma 55. So I have to calculate the distance between the data points and the second centroid. Right, square distance between the data points and the second centroid. You write all the values. The next step you can see in your here. Compute the distance between every object in the data set and the k centroids. We have done it. We have computed the distance between the 5 objects and both the centroids. Next, what we have to do, create a partition of a database by using minimum distance criteria. I have to partition my database using the minimum distance criteria. That is my next step. So what I have to do, you have to compare both the distance. Right? You have to compare whether the first object, right, the first object is close to first centroid or second centroid. If it is close to first centroid, the distance between the first object and the first centroid will be less. Right? You have to calculate the which this object is close to which centroid. Right? So here this distance is 221. First centroid, distance between the first centroid and the first data object is 221, and the distance between the second centroid and the first data point is 1. So which is the minimum distance? 1. So what you have to do, you have to place data point 1 in which cluster? Cluster 2. Cluster 2 will have data point 1. Similarly, you have to compare the distance of the second data point and the first centroid, that is 45, and the second data point and the second centroid, that is 65. So which one is minimum? 45 is minimum. So you have to keep the second data point in the first cluster. Second data point in the first cluster. Similarly, this is the distance between the third data point and the second centroid, 229, and the third data point and the first centroid, 769. So which is minimum? Second one is minimum. 229 is minimum. So this third data point should be placed in my second cluster. Similarly, you can compare the fourth data point. For second centroid it is 298 and first centroid is 218. So fourth centroid, it should be placed in your first cluster. Fourth data point, it is placed in first cluster. Next is distance between the fifth data point and the second cluster is 241, and the fifth data point and the first cluster is just 61. 61 is minimum. So I will be placing the fifth data point in my first cluster. I have partitioned my database. Now according to the steps, I have to revise the centroids using the clusters formed in the previous step. Right, now I have formed the clusters. Now I have to revise the centroid. How will I revise the centroid? Calculate the data point of the second object, fourth object and fifth object. Since you have 3 objects, you divide it by 3. Second, fourth and fifth. 156, 143, 156. 156, 143, 156 divided by 3. Similarly, the next one also. Right, why am I dividing by 3? Since we have 3 objects, you are supposed to divide by 3. Similarly, this you have to divide by 2. Here 2 should come, you will get some values. Now, these are the revised centroid. Now, what you have to do? You have to calculate the square distance between the data points and the revised first centroid, then the square distance between the data points and the revised second centroid. Right, first centroid is 151.67, 151.67 and 48.67. Second one is, here it is 161,63. So you have to calculate the distance between the data points and the second revised centroid. Right, after doing this, you have to compare both the distance and you have to partition your database, right, into clusters. So 123.50. So first data point comes in second cluster. 19.250. So second data point should come in first cluster. 561.50. Third data point should come in second cluster. 162.349. 162.349. So 162, it comes in first cluster. So fourth data point, it should be in your first cluster. Similarly, 93 will be in your first cluster. That is, object 5 will be in your first cluster. Now compare these two cluster values with the previous one. 24513. 24513. Now you can understood that the cluster got stabilized. You are supposed to repeat this process until the clusters are stabilized. Now your clusters are stabilized, it's fine, you can stop it. Right, so this is all about your K-means clustering. And we are having some advantages and disadvantages. The K-means algorithm is simple, easy to understand and to implement. It is also efficient in that time taken to cluster K-means. And no other clustering algorithm performs better than K-means. These are some advantages. And the user needs to specify the initial value of K. These 3 are disadvantages. Because we are supposed to specify the initial value of K at the very beginning. And the process of finding the clusters may not converge for some points. Right, as I said, you have to stop the process until the clusters are stabilized. What do you mean by stabilizing? You should get the same value in 2 continuous steps. And it is not suitable for discovering cluster shapes that are not hyperellipsoidal. Right. So these are the few disadvantages of K-means algorithm. Thank you.